Hi all, very good evening. Welcome to Chandan Likes English YouTube channel. In this session, I am going to discuss about sound. Okay, at first I will explain the topic, then next I will go through MCQs. Okay. Fundamental concepts of sound. Actually, what is sound? So, what type of energy it is? So, how the sound will travel from one place to another place? We are going to discuss in this session. So, everybody from starting to end. So, please listen carefully so that you can answer the questions which I am going to display at the end of the session. Okay. So, what is sound actually? It is nothing but it is a form of energy essential for understanding advanced topics like waves. Okay. So, what is sound actually? Sound is nothing but they are in the form of waves. Okay. Actually, sound travels from one person to another person in the form of waves. Okay. The particles which are present in the atmosphere. So, listen properly students. What is sound actually? How it travels from one person to another person. Nothing but the words we are uttering, the words which we are uttering, okay, these words will travel through the particles from one person to another person through vibrations, okay. Actually, these sounds are in the form of two waves, transverse waves and longitudinal waves. So, longitudinal waves means if I talk when my voice listen to another person, so that is like in a straight line. That wave is nothing but what? Longitudinal wave. What is transfer wave? Transfer wave is nothing but what? In this manner, like crest and troughs. Okay, wait a minute. In this manner. Wait a minute, students. Okay, longitudinal waves means in this manner and transverse means in this manner. Okay, crest to trough, perpendicular to each other. This form is known as what? Transverse waves. Next, sound is a form of energy that is essential for understanding advanced topics like waves. Okay, it is considered as energy because it can perform work such as vibrating the eardrum. Nothing but what students, when we are talking, what happens? Our voice will reach from one person to another person. Why? Because the particles which are in the atmosphere, so these particles, it will allow the sound which I make to enter into the other person's ear. Okay, how? In the form of waves. So, what are the two types of waves actually? Longitudinal waves and transverse waves. Okay, sound waves are in the form of longitudinal waves and transverse waves. Okay, so sound is produced exclusively through vibration. So, what I said? Actually, when we speak, the particles which are present in the atmosphere and through the vibration, these sound will reach from one person to another person. Every vibrating body produces sound and sound cannot be created without vibration. So, very, very important. Okay. For a sound to be created, a vibration is needed. If there is no vibration, so I am talking, that means there is some vibration is in my voice. So, there creates a sound. If there is no vibration, so like I am just talking very slowly. Okay. Can you hear any voice? No. Why? There is no vibration when I am speaking very slowly. Okay. When I am uttering words, so there are some vibrations and these vibrations will enter into the other person ear through the particles which are present in the atmosphere in the form of either longitudinal or transverse waves. Okay. This is what sound. Sound is nothing but it is a form of energy which moves from one person to another person through the vibrations created by the sound we do. Okay. Next, this is what all in the in this slide. Next, human audibility and frequency. So, normally, okay, how much hertz we can listen? Okay, how many hertz we can listen? Our human ear, okay, how much capacity our human ear can hear? How many, what hertz it can hear? Okay. Audibility range. A healthy human ear can hear within the frequency range of 20 Hz to 20,000 Hz. So, beyond this, okay, beyond this, our ear cannot hear that much of sound. Okay, our human ear, what is the range of our human ear? It can hear up to 20 hertz to 20,000 hertz. Beyond that or below that, our human ear cannot listen. Okay, very, very important thing, students. Okay, next, categorization. So, below 20 hertz. So, what I said? A human ear can hear a frequency having 20 hertz to 20,000 hertz. So, below 20 hertz, we can say it as what? Infrasonic. So, where these infrasonic sounds will appear means it is used by the dolphins for communication. Okay, you know all where the dolphins will live. It will live in the water. So, dolphins will communicate by this infra like sonic waves. So, the sound waves which are below 20 hertz are considered as what? Infrasonic sound waves. Okay. So, these infrasonic sounds, they are used by which aquatic animal? Dolphin for the communication. For their communication, they will use this infrasonic. Their sound will be below 20 hertz. Very, very important. In the similar way, ultrasonic. Ultrasonic means, so which animal will use this ultrasonic? Bat. You all know what is bat. So, in the night time, bat cannot see. But how can it reach to its target? With the ultraviolet sound it generates. Okay. So, which is the sounds above 20 hertz, above 20,000 hertz are considered as what? Ultrasonic. So, what is the frequency actually? Okay. Now, we are going to learn the terms related to this sound like wavelength, frequency, time period. So, these are all some of the terminology related to this sound. Okay. We all know. Okay, we have discussed many times about the sound chapter also in Chandan Loik's main channel. I have already gone through this sound unit, and now I am going to discuss about this in detail with some more information. Okay. So, what is the answer for this question, students? Frequency, it is measured in hertz, which is the unit representing the number of vibrations per second. Did you understand what I said? What is frequency actually? So, when I am uttering words or when I am talking, so my noise is like vibrating. The number of vibrations per second, that means in 1 second, how many vibrations are generated by our sound? That is known as what, students? Frequency. Very, very important. Okay. In general, what is frequency actually? Number of oscillations per second, right? But in sound, what is frequency? Number of vibrations per second. Okay. Very, very. Next, types of waves. So, as I said, so sound travels in two types of waves. Like one is transverse waves and other is longitudinal waves. So, longitudinal waves is nothing but what? Horizontal, and transverse waves is nothing but what? Perpendicular, like crests and troughs. So, this is very, very important. Okay. Waves are categorized based on how the particles of a medium vibrate. Transverse waves. Particle vibrate perpendicular to the direction of wave travel, forming crests and troughs. So, some particles will travel in this manner. Okay. So, sound travels in two types. One is transverse waves and one is longitudinal waves. Some particles will travel like in transverse waves and some particles will travel in longitudinal waves. So, what is transverse wave actually? So, when perpendicular to the direction of wave travel, okay, this is perpendicular to the direction of wave travel. That waves are known as what? Transverse waves. Bat, even bat also. Okay. Next, longitudinal waves. Okay, longitudinal waves, particles vibrate along the same direction as the wave travel. Okay, what is this longitudinal waves? As the particles travel, the sound also travel in the same direction. That is known as what, students? Longitudinal. Okay, bat is only correct answer. Next, characteristics of sound waves. As I told you, so now what are the characteristics of sound waves? So, what is wavelength? What is frequency? What is time period? What is amplitude? These are some of the terminology we use generally in this sound chapter. Okay. So, what is wavelength, students? The length of one complete wave. Okay, the length of one complete wave is known as what, students? It is wavelength. Nothing but this is wave. Okay, you know this. What is wavelength? In general, we know that the distance between one point to the other point of the wave is known as what? Wavelength. It is denoted by what, students? Lambda. So, we all know very well about this lambda. We all know very well. So, in a wave, the distance between one point of the wave to the other point of the wave is known as what, students? Wavelength. And it is denoted by lambda. And what is frequency? Just now we have discussed. What is frequency actually? Number of vibrations per second. In general, we say that number of oscillations per second. But here in sound chapter, number of vibrations per second is considered as what? Frequency. Okay, and the next thing is amplitude. What is amplitude? The maximum displacement of a particle from its mean position. Okay, the maximum displacement. So now I am like shouting. Okay, now I am like, what I am doing? I am shouting. Okay, the maximum distance my shouting can hear. Okay, now I am shouting now. So the maximum distance my sound particles here, that is known as what, students? Amplitude. Okay, what do you mean by amplitude? The maximum displacement of a particle from its mean position is known as what? Amplitude. So these are the some of the terminology used, which we generally use in our sound chapter. Okay, what is wavelength, student? The distance from one point of the wave to the other point of the wave is known as what, students? Wavelength. It is denoted by lambda. What is frequency? Like number of vibrations per second, it is denoted by what, students? Nu. So what is the relationship between a wavelength, speed and frequency? We have discussed many times. Okay, so speed is equal to frequency into wavelength. We have discussed many times. Okay, speed is equal to distance into wavelength. Speed of the sound, nothing but speed of the sound is nothing but what, students? Frequency into wavelength. This is very, very important formula. And next thing, time period. Time period is nothing but it is the reciprocal of frequency. Time period, it is nothing but what, students? It is the reciprocal of frequency. And the relationship between the speed and frequency and wavelength is speed is equal to frequency into wavelength. This is very, very important. Okay. Next. Speed in different media. So we have discussed many times. Okay. Light requires a medium to travel. Sorry. Light does not require any medium to travel. Light can also travel in like a vacuum. So what is the speed of the light, students? 3 into 10 power 8 meters per second. Did you get what I said? Okay. Light does not need any a medium to travel. It can even travel in vacuum also. But sound needs medium to travel. So either it may be a solid or it may be a liquid or it may be a gaseous. Sound requires a medium to travel. So the sound travels more in solids than in liquids than finally in gases. Okay, this is very, very important thing to be noted. So actually these questions, it was asked many times. Sound travels more in which medium? In which medium, students? In solids. Then next liquids and then next comes gaseous. So in the same way, sound speed varies significantly depending on the medium. So solids, in solids, sound travels about 15 times faster in solid than in air. So this is very, very important point to be noted. When compared to air, okay, when compared to air, the sound travels 15 times faster than faster in solids. So take one like a vessel and make a sound, students. How the sound will be? So it will hear as a resound. So that is a perfect example for this. Okay, what is this, students? Actually, sound travels 15 times faster. Okay. Okay. So what is pitch actually? It depends directly on frequency. For example, you all know how the mosquito will make a noise. Okay, the noise of mosquito, that depends on the frequency. That means number of vibrations per second. So how the mosquito's noise will be treated as? It is treated as a high pitch. That mosquito's voice or female's voice has a high pitch when compared to men's voice. Okay, very, very important. From this, what we have to understand, the pitch depends on the frequency. Frequency is nothing but what, students? Number of vibrations per second. Okay, when compared to men's voice, female's voice pitch will be more. Why? Because number of vibrations per seconds will be more when compared to men's voice. Not only that, students, like even the mosquito sound, okay, the mosquito will make a sound, right? So that sound is also having very high pitch. Okay, depends directly on frequency. High frequency results in a high pitch. For example, a mosquito's buzz are female voices. So these two are having high voices or high frequencies. That is nothing but indirectly it is having a high pitch. And while low frequency results in a low pitch, example, a lion's roar or male voices. A lion roar or male voices. So these two are considered as low frequency or low pitch. Why? Because number of vibrations per second are less. Okay, number of vibrations per second is less in lion's roaring or men's voice. So for this purpose we say as what? The men's voice or lion's roar is having very low pitch or low frequency. Okay. Next, after theory we will have MCQ, students. Don't worry. Okay, at the end of the session I am going to display MCQs. Why? Because directly we can't go to MCQs. We have to know the minimum knowledge regarding any topic. For this purpose, I am going to explain theory first and then next I am going to display MCQs. Okay. Next, loudness. What is this loudness actually? It depends on amplitude. So just now I have told what is amplitude, students? The maximum displacement a particle can travel. The maximum displacement a particle can travel is known as what? Amplitude. This loudness depends on the amplitude. For example, I am shouting. Okay, I am shouting. This shouting is known as what? Why are shouting loudly? Did you get what I said? That is nothing but the loudness depends on the amplitude. That means the particle which is in the atmosphere, how much distance it will travel when I shout, and that is known as what, students? Loudness. This depends on decibel. This loudness is measured in what, students? In decibels. For every like a physical quantity we will have an unit, right? For this loudness, the unit of the loudness is measured in decibels. Normal conservation is between 60 to 80 decibels. So if two persons are talking each other in a normal way, so that like decibels, that loudness is measured in 60 to 80 decibels. And sounds above, like I am shouting now. Okay, how much loudness? So I am shouting now, right? So how much loudness it is measured in means it is measured in 80 to 100 decibels. Can be painful or harmful to human ear. So remember, okay, 80 to 100 decibels above. Okay, 80 to 100 decibels above that our ears will cause pain. Okay, remember, students. So normal conservation loudness is measured in 60 to 80 decibels. So somewhat high means 80 to 100 decibels. Beyond that, if we hear that much sound of that much loudness, what happens to our ear? So our ear causes pain. Okay. Next, quality or timbre. Quality of timbre means what, students? This allows us to distinguish between different instruments or voices. So very, very important. Quality of sound or timbre of sound means this quality or these characteristics, it will allow to distinguish the different instruments, voices or noises. That means these are two instruments. Okay, remember, students, what is this characteristics actual means? So these two are different instruments, right? But these two are giving same noise. Okay, these two are the different instruments, but these two are giving same noise. So how can we distinguish these two instruments? By using this characteristics. What is this characteristic, students? Timbre. Okay, it depends on the unique waveform produced. Did you understand what I said? This allows us to distinguish between the different instruments or voices even if they have the same pitch and loudness. Okay, next. Reflection of sound. Okay, I think everybody know this. What is reflection of sound? So in a in an empty room or in a vacuum, for example, take a glass and keep it to your mouth tightly. Can you hear any voice normally? Okay, can you hear any voice? That is not, but can you hear a sound very loudly? No. You can hear the noise, but not as much as when we shout without keeping glass. Okay, so what is here actually? Laws of reflection. Sound reflects off hard surfaces similarly to light, where the angle of incidence is equal to the angle of reflection. So we have discussed many times. What is angle of incidence? Angle of incidence is nothing but what? Like when we apply a light ray onto this on the mirror. So what happens? It reflects back. That means in the same manner, the sound also reflects back. Okay, for example. Okay, so I am shouting in this steel bottle. I am shouting in this steel bottle. So in reverse, I am getting the reflection of my sound. Okay, in the same way, like how in light, angle of incidence is equal to angle of reflection. In the sound topic also, angle of incidence is equal to angle of reflection. For example, okay, take a steel vessel. Take a steel vessel. So beat it with iron rod. Okay, what happens, students? When you beat it, the sound which we get, even the same sound will be repeated. That means reflected. Ting. Okay, that is known as what, students? Angle of incidence is nothing but angle of reflection. Okay, in the same way, how like in light, how the angle of incidence is equal to angle of reflection, the same is repeated in the sound topic only. Even I have explained the example also. Take a steel vessel and beat it with the iron rod. You will get what type of sound, students? Ting. Okay, and that is known as what, students? Reflection actually. Echo. So I have discussed many times about this echo. So what is the difference between echo and reverberation? This is very, very important. Echo means nothing but, students, when you go on to, when you climb a mountain, and if you utter something high, okay, the same thing will be listened to you. The same thing will be come back to you at a time distance of 17.2 seconds. Wait. Yes. Okay, and echo is the reflection of sound arriving back at the listener. So at how much distance this echo will travel? This is very, very important. How much distance can this sound will travel? Means 17.2 meters. This value is very, very important. Okay, what is echo actually? Okay, if you go to an empty place and if you shout, okay, if you shout something like hi, it will come back to you. So how much the sound will travel and it will come back? Means the sound will travel to 7.2 meters and the same sound will be come to you, and that same sound is known as what, students? Echo. What is reverberation? Reverberation is nothing but resound. Reverberation is nothing but what? Due to multiple reflections. Okay, so I am in a, for example, I am in a room which I was surrounded by iron or something like hard substances. I am in a room and I was surrounded by a hard substances. Okay, so when I shout, what happens, students? This sound hits all the hardest metals and it will reflects back. That means multiple reflection happens to me. And that condition is known as what, students? Reverberation. That is the what? Difference between echo and reverberation. Echo is nothing but if we say hi, the resound will be high. That's all. But what is this reverberation actually? Multiple reflections of sound. Okay, when we stand in a room which I was surrounded by a hardest substances, so what happens? The sound will reflect to all the hardest surfaces which are surrounded around me. That means the sound will be comes back in a different ways. Okay, in echo I can hear only one word, but in reverberation I can hear multiple reflection sounds. For this purpose only, so when you look at the theaters or when you look at the studios also, so these are covered with sponges. Why? Because these sponges will not allow, okay, these sponges will not allow the sound to be reflected. This is the reason why the theaters or the studios are covered with sponges. Okay, why? Because this does not allow the sound to be reflected to the hardest substances. Okay, yes. To understand how travels, imagine a line of people. For example, so they are giving a very good example. Okay, so a group of persons are standing in a line. How that sound travels, they are explaining. Okay, a group of persons are standing in a row, and one person is passing the bucket. One person is passing the bucket. So how the person to person bucket is passing? So in the same way the sound will travel in this manner. Not only that example, students, for example, students are in a row in a school assembly. So one person pushed the one person pushed the one who is in front of him. So what happens, students? So that student will fall, even the person who is before him, he will fall, and the same will be repeated throughout the row. This is an example how sound will travel. Okay, did you understand what is echo and what is reverberation? Why the theater or a studio is surrounded by a sponges? Why? Because the sound must not be reflected. If a sound gets reflected, what happens? So multiple sounds will be come back to you, and that is not the good thing. So I am in studio right now. I am speaking. Can you hear any reflections of sound? No. Why? Because this studio is completely covered with sponges. Okay, in the same way, so why in auditoriums or in function halls, why they will wear carpets? Why? Because that carpets will not allow the sound to be reflected. Okay, yes, yes. Next, production and propagation. So production means sound is created by vibration. Just now I have told. Okay, how the sound is created? Sound is created by the vibrations. So I am speaking, there are some vibrations in my tone. Okay, and that vibration creates the sound energy. Okay. Next, propagation means sound requires a medium. How the sound will travel from one place to another place means sound requires a medium to travel from one place to another place. What are those mediums? It may be solid, or it may be liquid, or it may be gaseous. So when compared to liquid and gaseous, solid travels 15 times faster than air in gaseous. Okay, and when compared to air, liquids travel faster, and gas just travel 340 meters per second at room temperature. So remember each and every standard values. Next, it moves through a chain reaction, a vibrating object causing surrounding air particles to vibrate. Just now I have said, I have even explained you an example. Okay, if when a few students are in a row in a school assembly, when one person kicks the front person, so all the persons will be fall down. In the similar way, the sound will travel in the same manner. Okay. Next, reflection and application. Okay. So what is reflection actually? Sound bounces off surfaces. Just now I have told. Okay. Angle of incidence is equal to angle of reflection. So the thing which I am uttering, if the hardest surfaces are around me, the same thing will be uttered many times. That means the angle of incidence is equal to the angle of reflection even in the sound also. And the next, echo and reverberation. Just now I have told. Echo is a single reflected sound heard. Echo is a single reflected sound. So which we can heard after at a distance of 17.2 meters. This is very, very important. And reverberation is the blurring or persistence of sound due to multiple reflection. So just remember students, echo is nothing but single reflection, and reverberation is nothing but multiple reflections. Okay. Next, range of hearing. So just now we have discussed what is range of hearing, students. A normal human being can hear 20 hertz to 20,000 hertz. Okay, and his loudness will be, how much loudness he can listen means 60 to 80 decibels. Okay, and a dolphin can communicate with another dolphin at a decibels of how much? Just 20 hertz. And what is this actually used by bats? So who told old summer? Bats only correct. Ultrasounds are used by bats and dolphins. Okay. So used for cleaning delicate parts, detecting cracks in metal blocks, and medical imaging like ultrasonography by ECG. Even in ECG also we will use this ultrasounds. So which are about 20,000 hertz. Very, very important. Okay. Next, sonar. This is very, very important. So many times what is the full form of sonar is asked. So what is sonar actually? Standards for sound navigation and ranging. So what we will use this sonar? This sonar, okay, we will use it in submarines. So in order to detect the sounds under the submarines, okay, this sonar is kept in the submarine. In order to detect the underwater sounds, this sonar is used. Okay, how it is used? It reflects the sound is reflected, the sound is absorbed and gets reflected through this instrument. Sound navigation and ranging, mostly it will use in submarines. It will record all the noises which are happening in the underground and it reflects back the sound. Okay, so what it is doing? It is reflecting the sound which it is hearing in the underwater. Okay. Standing for sound navigation and ranging, this technology uses ultrasound to measure water depth or locate underwater object. So it is also used to measure the water depth and underwater objects also. Very, very important. To understand how sound travels through a medium, imagine a line of students in an assembly. If the last student pushes the one in front, the push travels all the way to the front. So just now I have discussed about this example. This is the way how the okay, bat and dolphins infrasonic and wool. Okay students. Next, SSC GD complete course is on available on our Chandan Logics app. RRB NTPC special batch complete course is also available on our Chandan Logics app. 0 to Hero complete course is also available on our Chandan Logics app. Railway exams complete course is also available. SSC exams complete course is also available on our Chandan Logics app. Bank exams complete course is also available on our Chandan Logics app. Bank SSC RRB combo course is also available on our Chandan Logics app. Reasoning and arithmetic, you can get these two books only at 999 plus delivery charges applicable. APPSC, TGPSC, essay constable courses are also available on our Chandan Logics app. So here comes MCQs. So I will display the question. If you know the answer, mention it in the comment section. So each and every student, so participate actively. Okay. So this sound chapter is very, very important in every examination. Okay, you can expect one question from this sound unit. Okay, so I am giving preference to the chapters which are going to be appear in your examinations only. Sound is best defined as a form of light energy, mechanical energy produced by vibrations, electrical energy, heat energy. Very good, very good. Next. Sound waves are classified as transfer waves, electromagnetic waves, longitudinal waves, surface waves. Yes, come on students. If you know the answer, mention it in the comment section. Even in the options, if the right answer is having two options, you can mention those two answers also. Yes, and the answer for this question is both 1 and 3. Okay. Next, the human audible frequency range is below 20 Hz to 20,000 Hz, above 20,000 Hz, 10 Hz to 10,000 Hz. How much frequency of vibrations can we make? Yes, yes. Very good, students. The students who are on live, all of you mention your answers in the comment section. So no one should sit idle. Why? Because this sound chapter is very, very important. Okay. In every examinations like SSC, GD, RRB, Group D, RRB, NTPC, SSC, CGL, this sound unit is very, very important. Very good. Sounds with frequency below 20 Hz are called ultrasonic, audible, infrasonic, supersonic. Yes, the sound below 20 Hz are considered as what? And these hertz, this sound is used for the dolphins communication. Okay, infrasonic, very good. The speed of sound is highest in gaseous, liquids, solids, vacuum. Each and every students mention your answers in the comment section. Yes. Very good, very good. Okay. And the answer for this question is what, students? The speed of sound is highest in solids. As I told you, in solids, it will be 15 times faster than gases. Okay. And then next comes liquid, and then next it travels more in gases. The pitch of a sound primarily depends on its amplitude, frequency, speed, wavelength. Just now I have discussed. Okay. So the pitch, actually what is pitch? Okay, it depends on what? Even I have given you the example. The voice of a, or the pitch of a female mosquito, or the pitch of a female voice will be more when compared to lion's roar or male's voice. So it depends on what? Yes, very good. It depends on what, students? It depends on frequency. Okay, the female's voice and mosquito's voice will be having high frequency. For this purpose, it is considered as it is having high pitch. In the similar way, lion's roar and men's voice, it is having low frequency, so that it is considered as what? Low pitch. What is frequency actually? Number of vibrations per second. Okay, when we are making noise, how many vibrations we are making per second, and that is considered as what, students? Frequency. Okay. Next. Loudness of a sound is measured in hertz, meters, decibels, seconds. So loudness depends on what, students? Loudness depends on amplitude. Remember this, very, very important. Okay. Loudness of a sound is regarded as what, students? Amplitude. What is amplitude actually? The maximum displacement. Okay, the maximum displacement a particle can reach from rest. Okay, from rest, how much distance the particle is reaching at maximum, that is known as what, students? Amplitude. And loudness always depends on what, students? Amplitude. Yes. And what is the answer for this question, students? And the answer for this question is decibels. How much a normal conservations will be, students? A normal conservations of a human beings will be 80 to 60 to 80 decibels. So beyond like if a person is shouting, his decibels will be 80 to 100 decibels. Beyond that, if a person can hear that much of a sound, so what happens? His ear cause pain. Okay. Next. The quality or timbre of a musical sound helps us distinguish loud sounds from soft sounds, high pitch from low pitch, different instruments playing the same note, speed of sound in different media. So tell me, students, what is the answer for this question? Very good, students. Very good. Each and every question is very, very important in all exams point of view. So students, don't even miss a single session which I am conducting daily. So we are having 3 channels: Chandan Loix Telugu, Chandan Loix main channel. Okay. Hertz is nothing but number of vibrations. Okay, number of vibrations per second. That is nothing but what, students? Frequency unit. Decibel is nothing but what, students? Loudness unit. How much we are shouting. Okay. Yes. Different instruments playing the same note. Very good. Sound cannot travel through air, water, iron, vacuum. I have discussed many times. Yes. I have told you many times, light can travel through vacuum, but sound requires a medium to travel. Okay? Yes. Vacuum is nothing but what, friends? Empty space. Next, an echo is heard when sound reflects from a surface at a minimum distance of approximately 5 meters, 17.2 meters, 50 meters, 100 meters. I have told you already. So, what is echo actually? Echo is nothing but it is a single reflection sound. Okay. I am at the top of the mountain. I am saying hi. After the sound is reaching how much meters, it is going to be reflected back to you. Okay. Yes, very good. That is what, friends. If I am saying hi at an a mountain, so after reaching the sound at 17.2 meters, it is going to come back to me, and that is known as what, students? Echo. It is nothing but a single reflection of sound. Okay, very, very important. Yes, very good, Sanjana. And next, the time taken by a vibrating particle to complete one oscillation is called frequency, wavelength, amplitude, time period. Tell me. The time taken. Come on, students. Number of oscillations per second is known as what? Read it properly. The time taken by a vibrating particle to complete one oscillation is called, yes, okay, time period. Time period, it is always a reciprocal of frequency. Number of vibrations per second or number of oscillations per second is known as what, students? It is frequency. And time period is always the reciprocal of frequency. Very good. The relationship between speed, frequency and wavelength of a sound wave is speed is equal to frequency plus wavelength. Speed is equal to frequency into wavelength. Speed is equal to frequency by wavelength. Speed is equal to wavelength by time. So, what is the unit of wavelength? Okay, what are the units of wavelength? Mention it in the comment section. And what are the units of frequency? Hertz. Okay, wavelength is denoted by lambda and frequency is denoted by nu, and speed it is denoted by v. Okay, and what are the units of speed? Meters per second. Yes, what is the answer for this question, students? Very good. Speed is equal to frequency into lambda. Next, ultrasound is commonly used in communication by humans, medical imaging, producing musical sounds, measuring air temperature. Ultrasound. So, what is ultrasound? What is infrasound? Okay, and what is normal sound? Normal sound is nothing but 20 hertz to 20,000 hertz. Infrasound is nothing but if it is below 20 hertz. Okay, and what is ultrasound? It is above 20,000 hertz. Very, very important, students. So, what I am going to discuss today in this chapter, from these particular points only you are going to get MCQs. Okay, students, so don't even miss a single point which I am discussing. And what is the answer for this question, students? Very good. Like ECG, okay, ultrasounds, very good. Next, sonar works on the principle of absorption of sound, reflection of sound, refraction of sound, diffraction of sound. Yes, yes. Sonar, what is the full form of sonar and how can we use that sonar and what is the process involving there? So, tell me, students, how it is used actually. Very good. Sonar, okay, we will use this sonar as an instrument to measure the depth of the underwater, okay, and even to detect any objects in underwater. Okay, so how it is working actually? It is giving the sounds which is happening in the underwater by reflection. Okay, very good. Sound navigation and ranging. Hi. Next, reverberation in a hall can be reduced by using hard smooth surfaces, Sound absorbent materials like carpets and curtains, metal walls, open windows. So tell me students, each and every students who are in the live session, this session is very important in your exam point of view. So don't even miss a single point which I am displaying. Yeah, and even if you know any extra information regarding this, you can mention it in the comment section. So in the live or after the live also you can mention it in the comment section. So no worries. Very good. So what is the answer students? Sound absorbent materials like carpets and curtains. As I told you, so what is reverberation students? Reverberation is nothing but multiple reflections of sound. Okay, if I am surrounded by a hardest substances, what happens? The things which I am uttering, this sound will be reflected to all the hardest substances and the multiple reflections comes to me. Okay, for these purposes only in either in auditorium or like in studios, in theaters, carpets are being placed or even it is surrounded by a sponges. Why? Because those things will not allow the sounds to be reflected. Okay students, yes, this session is useful for competitive exams only, Shanmukh, or even it is useful for your like 6th, 7th, 8th classes. Done. Okay, RRB NTPC complete course is available on our Chandan Loix app. SSC GD complete course is also available on our Chandan Loix app. 0 to Hero complete course is also available on our Chandan Loix app. SSC exams complete course is also available. Railway exams complete course is also available on our Chandan Loix app. Bank exams complete course is also available. Bank SSC RRB combo course is also available. Reasoning and arithmetic, 2 books are available at 999 plus delivery charges available. APPSC, TGPSC, essay constable courses are also available. APPSC, TGPSC group 2 courses are also available on Chandan Loix app. Single subject courses are available. So listen students, we have 3 channels, Chandan Loix Telugu, Chandan Loix English and Chandan Loix main channel. So we are going to conduct live sessions in 3 channels. So each and every students please subscribe to 3 channels so that if any time you have like a live session, you will get a notification. And not only that, all of you join in Telegram, Instagram and WhatsApp channels so that you can get any update regarding exam dates, exam like notification, etc. That's all for today. Let's meet in the tomorrow morning session with chemistry like a sound, sorry,